In this video, you will see how to create a roadway or railway alignment within the 3D Experience platform using the Civil Engineer role and the Civil Engineering 3D Design app. In this example, we already have a geolocated terrain and two geolocated points. Two different tabs are available for roads and rails. They contain similar capabilities but with specific behaviors. Three features are available for alignment: horizontal, vertical, and 3D. I will start with horizontal. I have now the choice between two profiles, road and highway, which comes with different customizable preferences. I can first define the type of road, cone or planar. Then the rotation mode used for the super elevation. We can then define the type of vehicle that will use the road, the speed and categories, and different parameters that will drive the design of the road. The number of lanes for your project can be defined, and you can use the plus button to add a new lane on one side. The number of shoulders can also be managed the same way. Finally, you can define which design rules will drive your alignment: radius rules, length rules, gradient rules, super elevation rules, and attainment methods rules. Those rules are defined by an administrator in the data setup and will allow you to check the compliance of your alignment all along the design process. By default, curves and spirals will be automatically created following those design rules. First, I will project the geolocated points on my alignment sketcher. Then I can start designing my alignment. The tools palette can be used to define a specific angle or length value for the tangent. I will define manually another point of intersection. If I edit the curve, I can handle parameters such as speed, length of spirals, radius, super elevation, and curve widening. By default, spirals and super elevation have been calculated using design rules, but you can bypass this by switching the automatic mode to false and input the value you want. The design rules checker can be used to verify that I am compliant with the design rules. As an example, if I change the radius of the curve to a lower value, the design checker will let me know that I am not compliant with the minimum radius value, which is set to 278 meters for a speed of 80 kilometers per hour. This can be fixed automatically by setting back the radius to the minimum allowed value. Stationing is handled through a dedicated panel. I can there increase the size of the stationing. I can define the label to be used and the start station for the project. Minor and major intervals can be set, displayed or not. Finally, station equations can be created by setting a station manually or inputting a specific stationing. Once your horizontal alignment is set, you can directly go to the vertical alignment using a dedicated icon. You are then asked to provide additional information, such as the terrain to be used. Please note here that if you have several geological layers, you will be allowed to pick all of those and display them in the profile. The vertical footprint of my terrain is then displayed along the alignment. Also, you can see the characteristic points from the horizontal alignment, like the transitions between line and spiral, spiral and curves, which are represented by the vertical line. If the terrain is too flat to be properly visualized, you can distort the scale following the elevation. Then, same way as for the horizontal alignment, you can design your profile and the tool palette can help you to input gradients or lengths for your lines. The vertical curves have been set automatically, and you can edit those to choose between arc and parabola and manage their lengths. Finally, a preliminary cut and fill analysis can be performed to get an idea of the cost of your project. This is based on a typical trapezoidal shape, and you can adjust its length and slopes. The volumes calculated are displayed in the panel and also stored in the tree, and you can update those when you perform iteration on your alignment project. Now we can combine both alignments to create the 3D alignment that will be used to create corridors, bridges, tunnels, and instantiate all the 3D components that will be part of your linear infrastructure project. Notice that the stationing is also displayed now in the 3D.